As the world's energy needs increase, it has become increasingly important that we move on from fossil fuels to more sustainable sources of energy that don't harm our planet as much. Solar energy has been in use for decades now. Now, scientists are researching perovskite material. It's a much more effective, cheaper, and lighter solar energy cell coating that can provide more solar power with less effort and cost. What is this new material all about, and what will its future look like? Join us today as we explain everything you need to know about this technology in this video. So without further delay, let's dive into the details. Conventional solar panels. Solar panels are a great way to power appliances, businesses, and homes by converting sunlight into electrical energy. The large black solar panels you see on homes and businesses are made of a bunch of solar or photovoltaic cells made of silicon semiconductors that absorb sunlight and create an electric current. These individual cells are connected together to make one solar panel. Solar power is pollution-free and causes no greenhouse gases after installation. Although they take up space, the panel installation reduces dependence on fossil fuel. This renewable, clean power is available every day of the year. Even cloudy days produce some power. You may wonder how this energy conversion works. When the sun shines onto a solar panel, energy from the sun is absorbed by the PV cells in the panel. This energy creates electrical charges that move in response to an internal electrical field in the cell, causing electricity to flow. Crystalline silicon cell. Crystalline silicon is a dominant semiconductor material used to manufacture the solar panel's photovoltaic technology. It has unique electronic, optical, thermal, and mechanical properties that make it suitable for this purpose. Also, the material is easy to obtain and manufacture. Crystalline silicon cells used for producing solar cells is assembled into solar panels as part of a photovoltaic system to generate solar power from sunlight. Crystalline silicon cells are made from silicon atoms connected to one another to form a crystal lattice. This lattice provides an organized structure that converts light into electricity more efficiently. Theoretically, it is even possible to power the whole of the United States solely through solar energy. We just need land to install the solar panels. This means that the technology could one day become highly efficient and ready to install. One such promising material is perovskite, and it is proven much more stable, energy efficient, lightweight, and cost-effective than the previous crystalline silicon cell. What is perovskite? Perovskite is any material with a crystal structure found with the formula ABX3. Scientists have come to the conclusion that they can manufacture a diverse range of man-made perovskite crystals by following the same material that has very useful properties. This material was first discovered as the naturally occurring material called calcium titanium oxide, or CaTiO3. But the perovskites used for solar energy conversion don't have to be mined from the Earth, as scientists can manufacture them by following the previously discussed arrangement. Perovskites are still in the technology research phase of their product lifecycle. Many teams are working to improve their stability and bring them into commercial use. There are abundant raw materials for perovskite manufacture all over the world, and the solar cells can be made using relatively simple manufacturing processes. This means that when the technology is fully developed, perovskites can rapidly scale into mass production. Perovskite panels will cost 15 times less per watt than modern silicon cell solar panels. Since engineered perovskite absorbs all parts of solar light, they produce the highest level of power output. The ultra-thin films promise high flexibility and more applications for the technology. How efficient is it? Until now, lab experiments have proven that perovskite is a promising material that may be used on a larger scale to cover solar panels. It is lightweight and requires less space, so it might one day cover skyscrapers, ships, and even cars for clean energy production. Even houses could be powered by a very small amount of liquid perovskite. In small area lab devices, perovskite PV cells have exceeded almost all thin film technologies in power conversion efficiency, showing rapid improvements over the past 5 years. However, high-efficiency devices are not always stable, and some are impossible to fabricate at a large scale. Maintaining high efficiencies while achieving stability in large area modules is necessary for the widespread deployment of perovskites. Continued improvement in efficiency in medium area modules could be valuable for mobile, disaster response, or operational energy markets where lightweight, high-powered devices are critical. The lowest energy of light that a semiconductor can absorb is called its band gap. Much of solar energy goes to waste when it hits a single-junction solar cell. The band gap of perovskites are easily changed, so several layers chemically tuned to absorb different parts of the solar spectrum can be stacked on top of each other. This stacking of solar cells is called a multijunction solar cell technology. It results in a solar cell with multiple p-n junctions that can produce electricity from a broader range of light wavelengths or extract more energy from each photon. This increases the cell's efficiency because single-junction solar cells can absorb only a portion of the solar spectrum. According to experts, the multijunction solar cell pushed the cell's efficiency from 30% to over 45% in theory. In practice, it is probably 30% to 40%. The efficiency increases with more layers, with a limitation of 86.8% in concentrated sunlight. The layering ability is the real selling point of perovskites. Applications of perovskite. As perovskites start coming into commercial usage, we will likely see them used in all traditional solar applications, like on commercial and residential rooftops and out in the fields. There is still work to be done on their stability and longevity, as solar panels have to withstand environmental factors. How long can they last? No one can rightly predict as yet. For shorter life applications, perovskites may be seen on cars, high-altitude drones fully powered by solar energy, solar wristwatches, and other mobile applications which don't require a long lifespan. Challenges that prevent perovskites from dominating the solar energy landscaping. Scientists and engineers have been working in controlled lab environments to enhance the capabilities of this new technology and make it ready for mass-scale production. Some of the challenges that scientists still face is the stability factor. To make perovskite last for years is still a work in progress. Outside, the temperatures can reach up to 80 degrees Celsius, so the material must withstand these high temperatures for years on end. High humidity is another challenge right now. The fragility of the perovskite material requires that the semiconductor is covered with a protective layer. Harsh simulated tests are performed on the panels to determine the strength of this material, but how they will work in the real world is still a mystery. This new material offers great promise for the future of renewable energy, but scientists must figure out the material's stability in the environment. That's it for today. We hope you learned something from our video. If you did, please like and subscribe to our channel for more amazing videos. Don't forget to turn on the notification bell so you don't miss any new uploads. Thanks for watching.